Hey guys, welcome back to Alphazans_Tech. If you're preparing for a fresher job, TCS, Infosys, Wipro, Cognizant, Accenture, any company, SQL is going to come up in your interview. Guaranteed. It doesn't matter if you're a developer, tester, data analyst, or even a support engineer, every single one of these roles expects you to know SQL basics. So starting today, I'm launching a complete SQL series on this channel, and this is Module 1, the Foundation. By the end of this video, you will understand what a database actually is, what RDBMS means, how SQL works, every major SQL command, all the data types, and all 6 constraints with real examples, real queries, and real outputs. Not just theory. I'll show you exactly what happens when you run each query. Before we start, hit that subscribe button and turn on notifications because I'm dropping a new module every week until this entire SQL course is complete. Alright, let's get into it. Slide 1. Screen shows the Module 1 of our SQL course, Introduction to Databases and SQL. We are going to cover 5 big areas today: RDBMS, SQL Overview, SQL Commands, Data Types, and Constraints. And I'm structuring every single topic the same way. First, I explain the concept in simple words, then why it's used, then a real-time example so it actually clicks, then the syntax, then a sample table, then a real query with its real output. So even if you're a complete beginner, you won't get lost. Slide 2. Here's our roadmap for today, 6 topics. Introduction to Databases, RDBMS, SQL Overview, SQL Commands, Data Types, and Constraints. Let's start from the very beginning. Slide 3. Topic 1. Introduction to Databases. Let's understand why we even need databases in the first place. Slide 4. What is a database? So, what is a database? A database is simply an organized, electronic collection of data, structured in a way that makes it easy to store, search, update, and retrieve. Think of it like a smart digital filing cabinet. Every folder, that's a table, has a fixed structure, and every file inside that folder, that's a row, follows that same structure. Now, why do we even need this? Think about the old way. Companies used to store records on paper or in Excel sheets. That breaks down really fast. Searching is slow, there's no security, the same data gets duplicated in 10 different places, and only one person can edit the file at a time. Databases solve every one of these problems. Fast retrieval, accuracy, multiple people accessing it at the same time, proper security, and automatic backup and recovery. Point at real-time time box. And here's the real-time connection. Every single time you open Instagram, book an Ola cab, or check your bank balance, there's a database answering that request behind the scenes in milliseconds. Slide 5. Real-time examples. Databases power everyday apps. Let's look at real companies using databases right now. Amazon and Flipkart, millions of products, prices, stock levels, and orders, all stored and updated every single second. Banking apps, account balances, transaction history, fund transfers. Here, accuracy is non-negotiable. One wrong digit and someone loses money. Swiggy and Zomato, restaurant menus, live order status, delivery partner locations, all changing in real time. College ERP systems, student records, attendance, marks, fee status for thousands of students at once. Instagram, billions of photos, profiles, likes, and comments retrieved instantly the moment you open the app. And hospitals, patient history, prescriptions, lab reports, available instantly to authorized staff. Pause. See the pattern? Every app you use daily is really just a really well-organized database with a nice interface on top. Slide 6. Relational versus non-relational databases. Now, quickly, there are 2 major types of databases. Relational, also called SQL databases, and non-relational, called NoSQL. Relational databases store data in fixed tables with rows and columns. Examples are MySQL, Oracle, PostgreSQL, SQL Server. These are best for structured data with clear relationships, like banking or ERP systems. Non-relational databases are more flexible. Documents, key-value pairs, graphs. Examples are MongoDB, Cassandra, Redis, Firebase. These are great for fast-changing, unstructured data like social media feeds or logs. In this course, we are focused entirely on relational databases because that's the industry standard, and it's what gets tested in almost every fresher interview. Slide 7. Topic 2. RDBMS. Let's understand the engine that actually runs SQL behind the scenes. Slide 8. What is an RDBMS? RDBMS stands for Relational Database Management System. It's the actual software, MySQL, Oracle, whatever, that stores your data in tables made of rows and columns and manages the relationships between those tables using keys. So to be clear, SQL is the language. RDBMS is the software that understands that language and does the actual work of creating, reading, updating, and deleting your data. Why does this matter? Because an RDBMS keeps your data organized and non-redundant, no copy-pasting the same data everywhere. It enforces accuracy through constraints and relationships, which we'll cover in detail later. It supports SQL as a common language, and it guarantees safe transactions even when hundreds of users are working on it at the same time. That's called ACID properties, and we'll touch on that later too. Real-time example. Think about an e-commerce site. It keeps customers, orders, and products in separate, related tables, instead of throwing everything into one giant messy sheet. That separation, with relationships between the tables, is literally the relational in RDBMS. Slide 9. Popular RDBMS in the industry. Let's look at the major players. MySQL, free and open source, powers Facebook, YouTube, and countless startups. Oracle Database, enterprise grade, heavily used in banks, telecom, and large corporates. PostgreSQL, open source and advanced, used by Instagram, Spotify, and Uber. SQL Server, Microsoft's RDBMS, common wherever companies use the Microsoft tech stack. Tip for viewers. If a job posting says SQL Developer, it usually means you'll be working with one of these four. Slide 10. Key RDBMS terminology. Before we move further, let's lock in some vocabulary you'll hear constantly. A table is a collection of related data, organized into rows and columns. For example, our employees table. A row, also called a record or a tuple, is one complete entry in that table. Think of it as one employee's full details. A column, also called a field or attribute, is one property that every row stores, like MP_name or salary. Schema is the blueprint, the structure, data types, and rules of a table. Primary key uniquely identifies each row. We'll go deep into this in the constraints section. Foreign key links a row to a row in a different table. Slide 11. Sample table, employees. Screen shows the employees table structure. And here's something important. I'm going to use this exact employees table for every single example in this entire module. MP_ID as our primary key, MP_name, age, department, salary, email, and join_date, each with its own data type and constraint. Keep this table in mind because we're going to reuse it again and again in SQL commands, in data types, and in constraints. This is exactly how real learning should work, one consistent example, not a new random table every 5 minutes. Slide 12. Topic 3. SQL Overview. Let's talk about the actual language now. Slide 13. What is SQL? SQL stands for Structured Query Language. It's the standard language used to talk to a relational database to create tables, insert data, fetch records, update values, and control who can access what. Here's the key idea. With SQL, you tell the database what you want, and the database engine figures out how to get it for you. You don't write a loop to search row by row. You just say, give me all employees in the IT department, and SQL handles the rest. One more important point for interviews: SQL keywords are not case sensitive. Select and select mean the same thing, but table and column names can be case sensitive depending on which RDBMS you're using. Why is SQL so powerful? Because it's universal. The SQL you learned today on MySQL transfers with only minor syntax tweaks to Oracle, PostgreSQL, and SQL Server. Every backend developer, every data analyst, every QA engineer uses SQL daily. Real example: a data analyst at Swiggy can write one SQL query and instantly know how many orders were placed in Hyderabad yesterday, instead of manually counting rows in a spreadsheet. Slide 14. The 5 sublanguages of SQL. Now here a slide that comes up in almost every interview. SQL is divided into 5 categories. DDL, Data Definition Language, defines or modifies structure. Commands: create, alter, drop. DML, Data Manipulation Language, changes the actual data. Commands: insert, update, delete. DQL, Data Query Language, retrieves data. Just one command, select. DCL, Data Control Language, manages access and permissions. Commands: grant, revoke. TCL, Transaction Control Language, manages transactions. Commands: commit, rollback, save point. Say clearly, this gets asked a lot. If an interviewer asks you, what category does delete belong to? That's DML. What about drop? That's DDL. Get comfortable with this table. We're about to explore every single one of these in detail. Slide 15. Who uses SQL every day? Data analysts write select queries to build sales and performance reports for management. Backend developers embed SQL directly in application code to save and fetch user data. QA and testers query the database directly to verify test data and reproduce bugs. Database administrators use DDL, DCL, and TCL to manage structure, security, and transactions. Personal note: whatever role you land, SQL will follow you. Slide 16. Topic 4. SQL Commands. This is the big one. We're going deep into every command category with real queries and real outputs. Slide 17. SQL Command Categories, full command list. Quick recap table before we dive in. DDL has create, alter, drop, truncate, rename. DML has insert, update, delete. DQL has select. DCL has grant and revoke. TCL has commit, rollback, and save point. Let's go through each one properly. Slide 18. DDL, concept and why. DDL, Data Definition Language, defines and modifies the structure of the database, creating, altering, or removing tables and databases. Important point: DDL changes are auto-committed, meaning they save permanently the moment they run. There's no undo button here. Why do we need it? Because every application starts with DDL. Before you can store a single row of data, you first have to define what the table looks like, its columns, its data types, its constraints. Real example: before Cognizant's HR system can store a new joiner's data, a developer first runs create table employees to define the structure. Slide 19. DDL syntax. Screen shows the code block. Here's the syntax. Create table, followed by the table name, then your columns with their data types and constraints in brackets. Alter table lets you add a column to an existing table. Drop table removes the entire table completely. Remember, create builds a brand new table, alter changes the structure of an existing one, and drop permanently deletes the whole table and all its data. Be very careful with drop. Slide 20. DDL example 1. Create table. Read the query slowly. pointing at each line. Let's actually run this. Create table employees, and inside the brackets, MP_ID as int and primary key, MP_name as varchar 50 and not null, age as int, department as varchar 30, salary as decimal 10,2, and email as varchar 50 and unique. Point at output. And the output, query OK. 0 rows affected, table employees created successfully. Notice it says 0 rows. That's normal, because create table only builds the structure. It doesn't insert any data yet. Slide 21, DDL example 2, alter and drop. Now let's modify it. Alter table employees, add phone varchar 15. This adds a brand new phone column to our existing table. And drop table interns. This completely removes the interns table. Output, column phone added to employees and table interns dropped successfully. Again, drop is permanent, so always double check before you run it in a real system. Slide 22, DML, concept and why. Moving to DML, data manipulation language. This is where we actually work with the data inside our tables, inserting new rows, updating existing values, or deleting rows. Unlike DDL, DML changes can usually be rolled back before you commit. We'll cover commit and roll back in the TCL section. This is honestly the most frequently used category in daily work. Every add to cart, every edit profile, every cancel order button you click on an app, behind the scenes, that's an insert, update, or delete running on a database. Real example. When you update your address on Amazon, the app silently runs an update statement on the customer's table. Slide 23, DML example 1, insert. Let's add a new employee. Insert into employees. Then we list the columns we're filling, MP_ID, MP_name, age, department, salary, email, and then values with the actual data, 106, Divya Nair, 25, IT, 47,000, and her email. Output, one row inserted, Divya Nair added to the employees table. Simple as that. Slide 24, DML example 2, update and delete. Now update employees, set salary equals 50,000, where MP_ID equals 103. This changes Arjun Reddy's salary specifically. Notice the where clause. Without it, this would update every employee's salary, which is a very common and very dangerous mistake. Always double check your where clause. Delete from employees where MP_ID equals 106. This removes Divya Nair's record we just added. Output, one row updated, one row deleted. Clean and simple. Slide 25, DQL, concept and why. DQL has just one command, select, but it is by far the most used SQL command in real jobs. It's used to read and retrieve data without changing anything. Almost every dashboard, every report, every search bar you've ever used is powered by select query running quietly behind the scenes. Real example. When you filter Flipkart products under 500 rupees, a select with a where price less than 500 runs instantly on their product database. Slide 26, DQL example, select. Here's our query. Select MP_name, department, salary from employees where department equals IT. Point at output table. And look at the output. A clean table with Ravi Kumar, Arjun Reddy, and Karan Mehta, all 3 IT department employees, with their salaries. This is the power of SQL, one line. And you get exactly the data you asked for. Slide 27, DCL, concept and why. DCL, data control language, controls WHO can access or modify data. This is managed by database administrators or DBAs. Why does this matter? Security. An intern should never be able to delete production data. DCL lets a DBA give exactly the right level of access to each user, which massively reduces the risk of accidental or malicious damage. Real example. A company gives its data analyst select-only access so they can run reports, but blocks them from ever running delete or drop on live tables. Slide 28, DCL example, grant and revoke. Grant select, insert on employees to analyst_user. This gives that user permission to read and add data. Revoke insert on employees from analyst_user. This takes away just the insert permission, why they can still select. Output confirms, privileges granted, and insert privilege revoked. Slide 29, TCL, concept and why. TCL, transaction control language, manages transactions, which are groups of DML operations treated as one unit. Commit saves everything permanently. Rollback undoes everything if something goes wrong. Save point marks a checkpoint you can roll back to. Why do we need this? Because real systems often need multiple related changes to succeed or fail together. Classic example. Transferring money needs to both debit one account and credit another. TCL guarantees this all-or-nothing safety. Real example. If a bank's fund transfer app crashes after debiting one account, but before crediting the other, rollback makes sure that money isn't lost. It's like the transaction never happened. Slide 30, TCL example, commit and rollback. Here's a realistic scenario. Begin transaction. Then update employees, set salary equals salary plus 5,000 where department equals IT. A bulk salary hike for the entire IT team. But then we realize it was a mistake, so we run rollback. Output, transaction rolled back. All IT salaries reverted to their original values. That's the safety net TCL gives you. Pause, recap. Alright, that's the complete SQL command section, DDL, DML, DQL, DCL, TCL, with real syntax and real outputs for each. If this is helpful so far, drop a comment saying Module 1 so I know you're following along. Slide 31. Topic 5. Data types. Let's talk about telling SQL exactly what kind of value each column should store. Slide 32. What is a data type? A data type defines the kind of value a column can hold, a whole number, a decimal, text, a date, or true and false. Every single column in a table must be assigned a data type the moment the table is created. Why does this matter? It keeps data accurate and efficient. You literally cannot accidentally store text in a salary column. The database also reserves the right amount of storage space, and it enables correct operations like sorting numbers numerically instead of alphabetically, which would give you wrong results. Real example. An HR system will straight up reject the word 25 typed into the age column. Because age is defined as INT, this single rule prevents an entire category of data entry errors. Slide 33. Numeric data types. INT stores whole numbers, like MP_ID equals 101. Decimal with precision and scale stores exact decimal numbers. And this is critical for money, like salary equals 45,000.50. Float stores approximate decimal numbers, like a rating of 4.5. Important tip, say this clearly. Always use decimal, never float, for money. Float can introduce tiny rounding errors, which is a disaster in financial systems. Slide 34. String and date-time data types. Char with a fixed length stores fixed length text, padded with spaces, like gender equals M. Varchar is variable length text, and it's the most common, like MP_name equals Ravi Kumar. Text stores large blocks of text, like a job description. Date stores just the calendar date, like join_date. Date time or timestamp stores date plus time together. Boolean stores true or false, like is_active. Interview tip. If asked char versus varchar, char is fixed length and wastes space with padding. Varchar only uses the space it actually needs. Always prefer varchar for most text fields. Slide 35. Employees table with data types applied. Screen shows the annotated table. Let's put it all together on our employees table. MP underscore ID as INT and primary key, MP underscore name as varchar 50, age as INT, salary as decimal 10,2, join underscore date as date, and is underscore active as boolean with a default of true. Slide 36. Example. Inserting correctly typed data. Here's an insert respecting every single data type. MP underscore ID 107, name Aditi Rav, age 26 as a number, salary 48,500.75 as a decimal, join underscore date as a proper date string, and true for is underscore active. Output, one row inserted, every value matched its column's expected data type. That's what a clean insert looks like. Slide 37. And now, topic 6, the last major topic of Module 1, Constraints. This is a favorite interview area, so pay close attention here. Slide 38. The 6 core constraints. 6 constraints we're covering: not null, unique, primary key, foreign key, check, and default. Let's go through each one exactly the same way: concept, why, syntax, table, and a real query showing what happens when the rule is broken. Slide 39. Not null, concept and why. Not null forces a column to always have a value. It can never be left empty when a row is inserted or updated. Why? Because some fields are mandatory for the data to even make sense. A record with no name attached is basically useless. Not null stops incomplete data from ever entering the table. Real example. An HR system can never save an employee record without a name. MP underscore name is marked not null. Slide 40. Not null, syntax and table. Syntax is simple. Just add not null right after the data type of the column you want to make mandatory. MP underscore name varchar 50 not null. Slide 41. Not null, query and output. Let's break it on purpose. Insert into employees MP underscore ID, MP underscore name, age values 108, null, 24. We are trying to leave the name empty. Point at red error box. And look at the output. Error. Column MP underscore name cannot be null. The database literally refuses to save this row. That's not null doing its job. Slide 42. Unique, concept and why. Unique ensures every value in a column is different across all rows. No duplicates allowed. One small detail for interviews. Unlike primary key, a unique column can accept one null value in most databases. Why do we need it? Certain fields must never repeat, like email addresses or usernames, or the system wouldn't be able to tell two records apart. Real example. No two employees can register with the same official email address. Email is marked unique. Slide 43. Unique, syntax and table. Just add unique right after the data type. Email varchar 50 unique. Slide 44. Unique, query and output. Let's try inserting a duplicate email. Insert into employees MP underscore ID, email values 109, and Ravi Kumar's email, which already exists on MP underscore ID 101. Output, error, duplicate entry for key email. Rejected immediately. Slide 45. Primary key, concept and why. A primary key uniquely identifies each row in a table. Here's an important fact for interviews. It automatically combines not null plus unique, so it can never be empty, and it can never repeat. And a table can have only one primary key, though that key can span multiple columns together, which is called a composite key. Why does every table need this? Because you need a reliable way to point to exactly this one row, for updates, for deletes, and for other tables to reference it through foreign keys. Real example. MP underscore ID is the primary key of our employees table. Just like your Aadhaar number or your college roll number uniquely identifies you. Slide 46. Primary key, syntax and table. Create table employees, MP underscore ID INT primary key, MP underscore name varchar 50. Slide 47. Primary key, query and output. Insert into employees values 101. Ravi Kumar, that works fine. But then insert into employees values 101. Another person, same MP underscore ID. 101 already exists. Output, error. Duplicate entry 101 for key primary. The database will never let two rows share the same primary key. Slide 48. Foreign key, concept and why. A foreign key is a column that references the primary key of another table, creating a link between the two tables. This enforces something called referential integrity. You literally cannot insert a value that doesn't exist in the table it's pointing to. Why? Because real-world data is connected. An employee belongs to a department. An order belongs to a customer. Foreign keys prevent what we call orphan records. Records that point to something that doesn't actually exist. Real example. Employees.dept underscore ID references departments.dept underscore ID. You cannot assign an employee to a department that was never created. Slide 49. Foreign key, syntax and table. Screen shows to tables, the parent and the child. Here we need to tables. First, departments with dept underscore ID as its primary key and dept underscore name. Then employees with MP underscore ID as primary key, MP underscore name, dept underscore ID, and then foreign key dept underscore ID references departments dept underscore ID. Remember this rule, the child table, employees, stores the foreign key. The parent table, departments, owns the primary key being referenced. Slide 50. Foreign key, query and output. Let's try assigning an employee to a department that doesn't exist. Insert into employees MP underscore ID, MP underscore name, dept underscore ID values 110, Rohit Das, 9. But dept underscore ID 9 was never created in the departments table. Output, error. Cannot add or update a child row, foreign key constraint fails. The database protects the relationship automatically. Slide 51. Check, concept and why. Check restricts the values allowed in a column by testing them against a condition. Only rows where that condition is true get accepted. Why do we need this? Because many business rules need to be enforced at the database level itself, not just in the application code, so bad data can never sneak in through any route, even a bug in the app. Real example. A company enforces that every employee must be at least 18 years old using check age greater than or equal to 18. Slide 52. Check, syntax and table. Age int check age greater than or equal to 18. The condition inside check must be true for every single row, or the insert gets rejected. Slide 53. Check, query and output. Insert into employees MP underscore ID, age values 111, 16, trying to add an underage employee. Output, error. Check constraint age underscore check is violated. Blocked instantly. Slide 54. Default, concept and why. Default automatically fills in a preset value for a column when no value is explicitly given during an insert. Why is this useful? Because many columns have an obvious normal value most of the time. This saves effort for whoever's entering data, and it guarantees consistency instead of leaving the column empty. Real example. A new employee's join underscore date defaults to today's date, and their status defaults to active unless you specifically say otherwise. Slide 55. Default, syntax and table. Join underscore date date default current underscore date. Status varchar 10 default active. Remember, default only kicks in when the column is skipped entirely in your insert statement. Slide 56. Default, query and output. Insert into employees MP underscore ID values 112. Notice we're only giving the MP underscore ID, nothing else. Then select star from employees where MP underscore ID equals 112. Point at output table. And look, MP underscore ID 112, join underscore date automatically filled with today's date, and status automatically set to active, even though we never typed either of those values ourselves. That's default working exactly as designed. Recap moment. And that's all 6 constraints: not null, unique, primary key, foreign key, check, and default. Each one a rule that keeps your data trustworthy. Slide 57. Practice and interview prep. Alright guys, we've covered a lot of theory and practical examples. Now let's lock it in with practice questions and the interview questions you're most likely to actually be asked. Slide 58 to 59. Practice questions. Read these out slowly. Encourage pausing the video. Here are 10 practice questions. Pause the video right now and try to write the actual SQL for each one before moving on. Create a student's table with roll_no, name, age, and marks. Add a not null constraint to the name column. Insert 5 sample records into your student's table. Add a unique constraint on an email column. Create a department's table and link it to employees using a foreign key. Write a check constraint ensuring marks are between 0 and 100. Add a default value of pending to a status column. Explain, in your own words, the difference between char and varchar. Write a query to alter a table and add a new column called phone. Identify which category each belongs to: DDL, DML, DQL, DCL, or TCL for delete, grant, commit, select, and create. Drop your answers in the comments. I actually read them and reply. Slide 60. Interview questions, basic level. Let's go through interview questions now, starting with basic level. What is a database? An organized electronic collection of data that can be easily stored, searched, and updated. What is RDBMS? And how is it different from DBMS? RDBMS stores data in related tables and enforces relationships and constraints. A plain DBMS may not organize data relationally or enforce these rules. What is SQL? Is it case-sensitive? SQL is the standard language to interact with relational databases. Keywords aren't case-sensitive, but table and column names can be, depending on the RDBMS. What's the difference between DDL and DML? DDL defines and changes table structure, create, alter, drop. DML changes the actual data inside tables, insert, update, delete. What is a primary key? A column or set of columns that uniquely identifies every row in a table. It can never be null or duplicated. Slide 61. Interview questions, intermediate level. Now intermediate level, these get asked a lot. Difference between primary key and unique key? A table can have only one primary key, and it can't be null, but it can have multiple unique keys, and those can allow one null value. Can a table have multiple foreign keys? Yes, a table can have several foreign keys, each referencing the primary key of a different or even the same table. Char versus varchar. Char is fixed length and pads with spaces. Varchar is variable length and only uses the space it actually needs. Delete versus truncate versus drop. Delete removes specific rows and can be rolled back. Truncate removes all rows quickly, but the table structure stays. Drop removes the entire table and its structure completely. Purpose of the check constraint? It restricts the values allowed in a column by enforcing a condition. For example, age greater than or equal to 18. Slide 62. Interview questions, advanced level. And now advanced level. This is where you separate yourself from other candidates. Can a table have more than one primary key? No, only one primary key per table. But it can be a composite key made of multiple columns combined together. What happens if you insert a value that violates a foreign key constraint? The database rejects the insert or update with a referential integrity error. The value must first exist in the referenced parent table. Difference between default and not null? Not null forces a value to be provided by whoever's inserting data. Default auto-supplies a value only when none is given. And a column can actually have both at once. How does a database enforce referential integrity? Through foreign key constraints, which block any insert, update, or delete that would leave a reference pointing to a row that doesn't exist. Difference between DCL and TCL. With examples, DCL manages user permissions, grant, revoke. TCL manages transaction boundaries within the changes a user is allowed to make, commit, rollback, save point. Slide 63, Scenario-based interview questions. And here's the section that really impresses interviewers, scenario-based questions. They're not asking you to define a term. They're giving you a real business problem and expecting you to pick the right constraint. You're designing an employee management system. How do you ensure no two employees share the same email? Apply a unique constraint on the email column. Your manager wants every new employee status to default to active unless stated otherwise. Apply a default constraint of active on the status column. You must ensure an employee is never assigned to a department that doesn't exist. Apply a foreign key from employees.dept_id to departments.dept_id. HR. Find some records saved without an employee name. Apply a not null constraint on MP_name. The company wants to reject any employee record with age below 18. Apply a check constraint age greater than or equal to 18. Say this directly to camera. Notice the pattern here. Guys, every scenario question is really just asking which constraint solves this problem. If you know your 6 constraints cold, you can answer any scenario question thrown at you. Slide 64, Assignments. Before Module 2, here are your assignments. Actually do these. Don't just watch. 1. Design a library management database. A books table with book_id as primary key, title as not null, price with a check greater than 0. And a members table with member_id as primary key, name, email as unique, and join_date defaulting to the current date. 2. Create a college database with students and courses tables, applying all 6 constraints appropriately. 3. Write 10 SQL statements of your own, covering DDL, DML, DQL, DCL, and TCL on a table of your choice. 4. Take the employees table from today's session and add 3 new constraints of your own choice with a short justification for each. Slide 65. Real-time scenarios across industries. And to really cement this, here's where these exact concepts show up on the job across different industries. E-commerce, like Amazon and Flipkart, unique SKU codes, check price greater than 0, foreign key linking orders to customers. Banking, not null on account holder name, check balance greater than or equal to 0, primary key on account number. Food delivery, like Swiggy and Zomato, foreign key linking orders to restaurants and customers. Default status of pending for new orders. College ERP, unique roll number, check constraint on age, foreign key linking enrollments to courses. To camera. This is exactly why companies test constraints so heavily in interviews, because you'll be applying them from day 1 on the job. Slide 66, Module 1 Recap. Alright, let's recap everything we covered today. What a database actually is, and why RDBMS became the industry standard. Core RDBMS terminology. Tables, rows, columns, schema, keys. SQL Overview. The 5 sublanguages, DDL, DML, DQL, DCL, TCL. SQL commands, with syntax, real queries, and outputs for each category. Data types, numeric, string, and date and time, and when to use each. And all 6 constraints, not null, unique, primary key, foreign key, check, default. That is a massive foundation. And if you followed along and tried the practice questions, you are already ahead of most freshers walking into an interview. Slide 67. Thank you outro. That wraps up Module 1. In Module 2, we're going deep into DDL commands. Create, alter, drop, truncate, rename. If this video helped you, smash that like button, subscribe to alphazans_tech, and turn on the bell icon so you don't miss Module 2. Drop your doubts and your practice answers in the comments below. I read and reply to every single one. Keep practicing, and I'll see you in Module 2.